It's Miss Roop here. I am going to be introducing volcanoes through a slideshow. Be sure to watch the video in its entirety because you will be using this to fill out interactive notes and ask questions tomorrow in class. All right, we're going to kick it off here by just looking at some of our objectives or what we want to learn. We want to learn the parts of a volcano, the 4 different types of volcano, the processes that form volcanoes. I think you guys might know that one already. And then we also want to know where volcanoes are located on Earth. First and foremost, let's talk about what a volcano is. A volcano is a cone-shaped mountain or hill that has a crater or a depression at the summit. The summit is simply another way of saying the top of the volcano. A volcano forms around a vent in the Earth's crust where lava, steam, and ash are expelled. A volcano can erupt continuously or it can erupt at irregular intervals, meaning it can have bursts of lava being shot up out of the volcano. And then again, there are 4 types of volcanoes. Now, before we get too much further, let's learn about the parts of a volcano. You can go ahead and disregard over here these instructions. We aren't going to be doing that, but I do want you to pay attention to the different types of a volcano as I go through them. First and foremost, we have magma. Magma is molten, meaning liquid rock, underneath the Earth's surface. This is what it is when it is in the crust and the mantle. When magma is under the earth, it forms in a large underground, almost like pool, and we call that the magma chamber. You can see it is right here, that magma chamber, where the magma is just sitting and waiting to erupt out of the volcano. The main vent is the weak point in the Earth's crust where the magma rises above out of the earth and comes to reach the surface. So again, that is right here, where the Earth's crust is meeting the top or the mountain. Right. What's more is at the top of the volcano, we called that the summit earlier. The top of the volcano has a circular basin where the lava shoots out of, and that is called a crater. The volcano also has an area right here, this line. Well, it could have multiple areas, but we call that the secondary vent. That's where magma reaches the surface just in other areas. So it comes out of the volcano, not at the crater here, just at a secondary vent. And then the secondary cone is right here. It's the exit of the secondary vent. And essentially what it is the lava is building up around the exit of that secondary vent into the shape of a cone. Over here you can see spews of lava coming out. These large projectiles are thrown through the air and they are very, very dangerous. We have an ash cloud up here. This is small pieces of pulverized rock, minerals, and volcanic glass created during the eruption. The pyroclastic flow over here is the hot gas and rock that's moving away from the volcano. So it's essentially that lava flowing down the hill or the mountain. And lastly, we know that lava is the molten rock when it's above the Earth's surface. So now that you have an idea of the features of a volcano, let's go ahead and look at what a caldera is. So a caldera is a large basin-like depression resulting from the explosion or collapse at the center of a volcano. So maybe you've heard of Crater Lake in Oregon. It's a beautiful example of a caldera. The center island here is called a wizard island. So essentially the center of a volcano collapses and makes this huge basin and fills up with water. 4 types of volcanoes. We have a composite volcano. Sometimes we call that a stratovolcano. We have a cinder cone volcano, a shield volcano, and we have a lava dome. So, starting off with our first type of volcano, a composite volcano. It is large and it is symmetrical, meaning that it could have a line down the middle and it would be the same on each side. These are built by layers of lava flowing, volcanic ash, and cinders and bombs, lava bombs. This can create an explosive eruption. Lava can fly out of there, looking much like an explosion. Examples include Mount Fuji in Japan, Mount Hood, Mount St. Helens, and Mount Rainier in the U.S. Our second type of volcano is called a cinder cone. This is a small cone-shaped volcano with steep and angled sides. So it's short, but it's steep. Lava spews into the air during eruptions, and then it falls as cinders onto the sides of the volcano. It's built over just a short period of time, and examples of this are the Paricutin in Mexico and the Sunset Crater in Arizona. Our third type is a shield volcano. The side of this volcano kind of resembles a warrior's shield lying on the ground, as you can kind of see here, and that's where it gets its name. These are formed by thick lava flowing that flows slowly, and it's not really explosive, so it just kind of oozes out. The largest volcanoes that we have are shield volcanoes. Examples include the Mauna Loa on the Big Island of Hawaii and the Galapagos Islands. Lava dome volcanoes are our fourth and final volcano that we're going to be talking about. In here, the lava is too thick to flow a great distance. It cools and it piles up all around the vent. So you can see here, it's kind of cooled off before it's flowed a lot. That's because it's very thick. So as that dome continues to grow, it spills loose fragments down the sides. Sometimes these occur within craters of other volcanoes. An example or two of these would be Mount Pelee in Martinque and Lassen Peak in California. So igneous intrusions. If the word intrusion sounds familiar to you, that's a good sign. An intrusion is we'll get back to an intrusion in a second. But when lava cools and hardens, it forms this type of rock, an igneous rock. And intrusions form when magma cools and solidifies in the surface. So you remember that we talked about rock formations and aging of rocks in the past. And we had those issues when lava would ooze into the cracks, it would be called an intrusion. After many years, erosion and uplifting can cause these features to be seen on the Earth's crust. You can see some examples. We have the batholiths, the laccolith, the sills, and the dikes. Here are some pictures of igneous intrusions on the Earth's surface. We have a sill. We have a dike here. You can kind of see it very well. And we have Devil's Tower. That one should sound familiar to you. So be ready to discuss what an igneous intrusion is. If you have questions, please write them down so that we are able to talk about them in class tomorrow. Plate boundaries. I'm sure you guys have never heard of this before. Just kidding. Plate boundaries. So plate tectonics is the theory that the Earth's outer crust, the lithosphere, is divided into plates that glide over the plastic-like and less rigid asthenosphere. The plate boundaries where most volcanoes happen are around the Ring of Fire, and we'll get there here in our next slide. You guys know the Ring of Fire is an active volcanic region. Kind of have the ring here. Remember, it kind of looks like a duck too. See its little beak there. California's over here. Alaska's up here. Converging boundaries, just to review real quick. So the more dense oceanic crust will slide under the continental crust, creating a subduction zone. With heat and pressure, the less dense oceanic crust will melt, and this melted crust works its way to the surface, which forms volcanoes. So if you look here, melted crust is working its way to the top, forming that volcano. We talked about the Cascade Mountains in Oregon and Washington. An oceanic crust slides under another oceanic crust in this type of converging boundary, and it can also create a subduction zone. Heat and pressure will cause the oceanic crust to melt, and the melted crust will work its way to the surface and again form another volcanic island. Examples would be the Aleutian Islands in Alaska. Diverge. Remember, diverge is when two plates are pulling apart. Divergent plates create rift valleys, and these form on land when two continental plates are pulling apart. Active divergent boundaries also occur between oceanic plates at the mid-ocean ridges. So when two oceanic plates pull apart, it makes a divergent plate boundary. Both of these areas cause volcanoes to form. Examples are the Rift Valley in Africa and the Mid-Atlantic Ridge. Hotspot volcanoes. So in the mantle, there are areas that are very hot compared to the areas surrounding that part in the mantle. This creates like a plume that eventually breaks through the crust as a volcano. So if you look here, it's very warm here, and eventually it's so warm it's going to break through the crust. This usually happens in the middle of a plate rather than at the boundary. That is how the Hawaiian volcanoes are formed. Hawaiian Islands. So, Hawaiian Islands, magma rises until it erupts on the seafloor. It hits the cold water, and it's not, remember, cold. It's just the water temperature is colder than the inside of the earth. So it hits that water and hardens into an underwater volcano. After many eruptions, it breaks the ocean's surface. Only the island sitting over the hotspot is increasing in size. So it's growing right here, and it's pushing out. There's a new island forming right now, but it has not broken the surface. So a volcano that is dormant means that it's quiet now, but it could erupt again. So Mount Fuji is dormant right now. It's not erupting, but it has the potential to erupt. An active volcano has erupted recently, and that would be like Mount St. Helens here. And then an extinct volcano is unlikely to erupt again, and that's like the Kohala in Hawaii. So, for tomorrow, I want you to think about some of the features of the volcano. If there was anything that challenged you, that was difficult to understand, write it down. I want you to be able to describe the 4 types of volcanoes, describe the process that forms them, and then think about where active volcanoes are on Earth. Come with your questions, come ready to discuss, and we will go from there.